Okay, we can start now. I am Professor Jelena Vasiljević from University of Belgrade, Union, Serbia. I am Professor of Artificial Intelligence, Neural Networks, Genetic Algorithms, many subjects. Applied Artificial Intelligence on PhD. I have my subjects because my PhD, which was many times awarded, is medical image analysis in detection of cancer and prediction of efficiency of chemotherapy. So I will present some applications of artificial intelligence in cancer diagnosis. Is it okay? You can hear it. So why, first of all, do you maybe know this image in background? What is it? Do you know? Maybe ask students. Are you familiar with this image? Yeah. No, fractals, you have heard. And main characteristic of fractals is that each single part, if you zoom this picture, you will get again the whole picture inside. So that characteristic is self-similarity. It was applied first of all in theory of chaos in quantum physics, and that's why it was some idea it can be applied in explaining of carcinogenesis. It's not really chaotic as it used to be theory. So we can explain that multiplying of cells with fractal equations and multifractal equations. That's why it was not only my idea and other scientists to apply it on data sets with images of cancer. So it was, I have PhD of electrotechnical actually sciences, but my collaboration usually is with medical team. So my co-mentor were on PhD Jelena from Institute of Pathology, because we used to work first of all with microscopic images, taking biopsies from bones. It was very interesting that they take sample of bone usually for leg bone, and searching for primary cancer. It is metastasis in bones, and they are searching for primary cancer. Is it on lung, breast, or any other organ? So it was really fantastic for me that they can distinguish like that different tissues, different organs. You will see some example of images. And we used to cooperate with Oncology Institute. Unfortunately, in my country, Serbia, there is maybe not officially, but like epidemic of cancer. That's why. And my father died a long time ago because of lack of therapy and diagnostics. That's why I'm doing this in his honor, and to maybe save other patients. Okay, I worked 19 years in Institute Mihailo Pupin, University of Belgrade, and parallel school computing. Now I'm only on school of computing because it's not allowed to be scientist on two places. Some political stuffs. Okay, but I'm trying with my PhD, master, even primary students, even on first year, they are doing like this science. Very enthusiastic students I have. So it's about me. I'm teaching in genetic algorithms, robotics, used to teach fuzzy logic, knowledge-based systems. It was on master study. Okay, I said why fractals and multifractals. and some advantages why we should use fractal and multifractal image analysis comparing to other medical image analysis is that there is full of filtering. There is no degradation of that original image. That is big benefit. Okay, and as I said, fractals can describe pathologic cancer structures and can explain that mechanism of growing tumor. Okay, in this project, actually it was my PhD. As I said, we had biopsies taken from bone metastasis, usually from leg, and searching for primary lung carcinoma, breast, and renal cells carcinoma. Because usually I ask a medical doctor where they have some question, there is no need to apply it when they are sure in some diagnosis. I used program FRACLAC from Australia in cooperation with university in Australia. I was twice teaching there some time, and collaborating with their professors, we made that program, FRACLAC, we made it for big data sets, not just image per image, as it was in Institute in Brienne in Paris. There is also FRACLab program for this, but for my master degree, actually, I had a comparison between FRACLab and FRACLAC, and I found it's much better FRACLAC for big data sets. And for statistical data analysis, I used data registration. I found it better than SPSS, and it was trial version free for 1 month, but it's much better. So there were 6 multifractal parameters. I will not explain it, but in multifractal analysis, as it is named, there is multi-parameters to explain, so it should be better statistical results after that. My first hypothesis, general hypothesis, was that all those previous mentioned 6 multifractal parameters will be in correlation with those primary 3 tumors. You will see results. I had 1,050 tissue images. That is really a lot because I went to take a picture for that. There is some digital data of microscopic images nowhere in China, in Australia, as I know, because I thought it is small data image base, but actually they were always surprised how come that I have so much images. Some theories that pathologists want on that way, not putting outsourcing, open access, to put it, I don't know, safe, maybe their diagnosis. But it is big problem because there is no on internet, open databases, especially of microscopic images. Nowadays, after COVID, especially, there are some good databases, but always questioning, is it on the same uniform conditions taken, in the same hospitals and same scanner or MR. This was actually, as I said, biopsies, microscopic images for 3 groups. So you can see example of metastatic carcinoma, which was a result of primary cancer of renal cells. You will see it's really all similar. It's very hard to distinguish. So very hard job for pathologists. It was in breast primary carcinoma. And third example, it was in lung. As you can see, it is all so similar, it's very hard to distinguish. They have their methods with this coloring, histopathological, some methods, but it is very hard to distinguish. And after that, it's not just applying those methods, maybe with counting, coloring, and other methods. After that, pathologists, they say they send that patients on other maybe invasive and long-lasting and expensive, other diagnostic methods. And patients with, especially with metastasis, they don't have time, So in that order, to prevent that, to short that time and to increase accuracy, it was idea to apply like this algorithms. After this multifractal, we applied neural network CNN convolution filters. You will see these were results after applying FRAC-LAC. It put its binary. And after that, we got these results. For lung carcinoma, it was accuracy over 78%, which is very good. According, there is 3 groups. For breast, it was over 73%, and for renal, over 76%. These are very, very good results. And I gave that program to that clinic, but it's not really applying, unfortunately. Some idea for further researchers is to apply the same on other types of metastatics, of other types of primary cancer. And you will see now results for predictions of breast cancer chemotherapy response. We also had 3 groups, and these results were very, very good. This is very important because state of the art is that when a patient, usually a woman for breast cancer, come, they just can tell them according to their, health, this therapy will, there are statistics that for this type of cancer, this therapy will have some statistics, but on this way we can apply personal medicine, personal therapy, which is very, very important, which is maybe, I don't know, in America or I don't know, other countries is already, in Australia is already now applying, that you can tell for specifically that patient what is statistical for predictions for applying that therapy. In this case, this special kind of chemotherapy. And we got results over accuracy over 91%, which is very, very good. We had these 3 types of group with partial pathologic response, complete response, and progressive disease. So as I said, for first group, it was over 91%, which is very good. And here were applied CNN, neural networks. So also recommendation, and for this type of applying and multifractal and CNN is to try to apply to make those statistical results. And for other types of chemotherapy or other therapies, there are new therapies, biotherapy, many, maybe even better therapies with low sub-contraindications, because chemotherapy and radiotherapy are really therapies for cancer, but with high contraindications. They are killing all cells, and health cells. And so my not only mine, but maybe some recommendation, is on targeting, like is gamma knife for radiotherapy, targeting big gamma waves to tumor of brain. On this way, in Australia, they have, as I know, still in experimental, that is simultan. In the same way, it is screening and radiotherapy. On that way, you can prevent some mistakes and integrated already some errors in any device. So always some point is on targeting, either radiotherapy, either chemotherapy or others. So for chemotherapy, some solution is nanobots. They can take that combination of therapy for each cancer. They told me on Institute of Oncology that every cancer is unique. And I think it is maybe for any disease, but especially for cancer, that any cancer, any patient has unique some resolution for that. So it takes time, resources, money to make that combination, but it will be solution. And in America, in Hospital of Houston, we had some collaboration with Professor Mauro Ferrari, who is really, really high position for nanobots. They cured a patient with terminal disease of pancreatic cancer, which is state of the art, it's not treatable at all. And they cured it 100% with nanobots. So it's really good, but really high prices, and they will, I don't know when and will they approve it, nanobots, FDA. They say it will be in Europe before in America, but it is solution, but very, very, very expensive. So we had, with my best students and colleagues from Institute, we had many competitions for startups. We have been in finals, I don't know, twice. In China, I was in final for innovation, but never won. Always some data protection, some issues, I don't know, but okay. We have still this idea of medical research platform. We offer to our academy and clinics. Now we offered, before COVID, we offered to the biggest private med group in Serbia, but still no answer. Maybe we can have like this collaboration. On this way, I invite all of you, and here and online, that we can all collaborate and make online, like big open source databases of images in real time, any types, ultrasounds, MR, magnetic resonance, scans, microscopic, although it is hard to get, but okay. And my idea is to maybe, prevent going on biopsies, because it is too much invasive and there are errors, especially because they, at least in Serbia, they do it like that they scan it and then they took biopsies, and there are many errors, they must repeat it. It is really painful, as I know. And for adults, and especially for children. My next project was with the Children's Hospital. So idea of this project is to put it online in the world, all databases of images, and to exchange and machine learning algorithms, statistical algorithms, to get in real time any images, because as you know, you're doing neural networks, all when you have more and more samples, your neural networks and algorithms getting much better and better, like our brain, yeah. So, and another benefits of that platform would be that you can, and as And as patient and as doctors, everybody wants another opinion, to find some doctor house, to check maybe it's something new disease. So in this way, you can anonymous ask, and check and get second and third opinion. Okay, so this would be those platform functions. Database, as I said, exchange of analysis, educational, as I teach my students on computer university, it is more maybe better for medical students that you can show them this picture is for this type, after this applying this and this therapy. I think there are many benefits. And as I said, sharing those knowledge between doctors, and patients can ask for another opinion. Okay, of course, because everybody asked for that, and I must sign those contracts of data privacy. Of course, I never knew any name of patient. There is only that one unique number, so it will be protected, and we will have data of all images and history of that patient. It means health history. Because in Serbia, unfortunately, the patients go to one clinics, then to others. You got lost of their history, and you can make over radiation. In our life, we have a critical dose of possible radiation. Nobody, rare of us know that, but when you even scan your teeth, it's limited for good health. Okay. This is all I said. Okay. I didn't put it here, but I can tell you for results for that children hospital that we had over 95% of accuracy in prediction of cancer, in bone cancer at children. It is very, it should be very useful, but unfortunately it's not applying still. But on this way, I invite you all that we can collaborate and share those images or share our algorithms, So that's it for me. And these are another my favorite fractals.